Hi, this is the first video in a lecture series on physics. The idea here is that if you start with me and know nothing about physics, everything will be self-contained, and if you do the problems, follow along, you'll go all the way from knowing nothing to a graduate level understanding of physics. Also, just have a deeper understanding of the universe in general. So, what is physics? Physics is a process of turning a question into an experiment and then gathering data and looking for patterns, right? It turns out physics works really well because the universe has lots of patterns. So the very first thing I want to talk about is just a problem solving strategy that you should try and follow as we go through learning physics. An acronym for the problem solving strategy is IC. Here, I stands for identify, S stands for setup, E stands for execute, and the last E stands for evaluate. So the identify, basically what you're doing is you're going to find the unknown and known quantities in a problem, and this just helps clarify what you have and what you need to search for. Um, in setup, you're going to draw a sketch, find equations you should use, and then come up with a plan for the solution. Then the third thing, execute, that's when you're going to solve the problem, follow your plan. And then finally, you'll evaluate. So you're going to look at, does your answer make sense and are the units correct? And we'll go a little bit more over this in the next lecture. But for now, like, what are units? What is a unit? So a unit is some standard of measurement. So isn't really very clear, but when we get some examples, I think it will make more sense. So there's three fundamental units. There's mass, time, and length. So mass, we're going to use the kilogram as our standard of measurement, or abbreviated by kg. And this is defined by some fundamental constants of physics. You don't need to know all the specifics, but for now, you probably have experience with pounds. So you can think of a kilogram, it's around 2.2 pounds. The second fundamental unit is time, and we're going to measure that in seconds. It's abbreviated by just S, and it's defined through the frequency of a certain microwave radiation from a cesium-133 atom. Okay, also just like this picture below, it's the same thing, the same second that you see on a stopwatch or clock. Okay. Um, then how do we measure length? Um, Length, we're going to use the standard measurement of the meter, abbreviated by M, and this is actually defined through the speed of light. But also, you've probably seen a meter stick. That's a good way to think about what the meter is. Um, it's the length of a meter stick, right? So when we say something's 5 meters, it's 5 of those meter sticks you can say put on top of each other. Okay, so why are units useful? Units are useful because whenever we have an equation, like in this case, x is equal to y, um, the units must be the same on both sides, right? So if x has the units of u, then y must have units of u, right? That's the only way they would be the same thing. Okay. So because it doesn't really make sense if we have x oranges to say it's equal to y apples, right? It's two completely different units, two different standards of measurement, right? Or another example, if we have 5 cars, it's not equal to 2 tires. Or um, if we have 3 cars, it's not equal to 2 houses, you know. Basically, anytime you have an equation, the right and left side units need to be the same. At some point in your physics career, you're going to have to convert units. So let's look at this problem. It says convert 5 feet a second to meters a second. Okay, and it tells us, no, 1 foot is equal to 0.3048 meters. Okay, as you can see, 5 feet a second, that's a length measurement divided by seconds, and we want to convert it to our standard of measurement for length, which is meters, so to meters a second. So It basically comes down to just multiplying by 1 in fancy ways, and I'll show you what I mean. So if we have 5 feet a second, then what we're going to do is multiply it by 0.3048 meters divided by 1 foot. So why didn't we flip this? The idea is we want feet on the top on the left side and feet on the bottom on the right side. So then they cancel, okay? And you can think of it like when you multiply like 5 times 1/5, right? Um, they divide out. So these units, the feet units divide when you multiply it a top and a bottom, okay? And then when you multiply that out, notice that you get 1.524 meters a second, right? Just meters is left on the top. So um, 1 foot is equal to 0.3048. So all we did was multiply by 1 here, technically, okay? Now we could also flip the second fraction we multiplied by, and but that would give us feet squared over meter times second, right? Nothing cancels there. So that's kind of how you can figure out, okay, am I dividing by 0.3 or am I multiplying? Okay, so really the only way you're going to learn physics is you need to pull out a piece of paper and work through some problems. So I'm going to stop here for a moment, then unpause it, and I'll guide you through it. Okay, so hopefully you paused and did that. So in this problem right here, we're saying convert 5,000 inches an hour to meters a second. And it tells us two things to know. 1 meter is 39.37 inches, and then 1 hour is 3,600 seconds. So what's the solution here? We're going to take our 5,000 inches an hour, and we're going to multiply by 1 meter divided by 39.37, right? So and again, that second fraction is just 1, because 1 meter is equal to 39.37 inches. Okay, and the inches are going to cancel. So now we have 5,000 meters over 39.37 hours, right? Okay, and then next thing we're going to multiply. We want to get it into seconds, so we're going to multiply by 1 hour divided by 3,600 seconds. And now the hours cancel out, and we can just multiply everything across, and we get 0.035 meters a second. And hopefully you got that same answer. Okay, so that's all we're going to go over today. Here's a few problems. Solve these problems, and I'll leave the solutions in the description, and I'll see you guys next time.